massive earthquake, guys, another massive earthquake, 7.7, and they keep upgrading it. They started out at 7.4, then I looked like 7.5, now we're at 7.7, and boy, the aftershocks are hitting. Boof, boof, boof. 6.1, the highest one, but so many. Look at that list. Tsunami situation has now escalated. Absolute dire tsunami warning. And if you look at the location, yes, it is offshore. It is offshore of a densely populated area and not that far offshore. That's the problem. So if you saw the first reports that were calling it a 6.9, guys, those numbers, they are already outdated. Another big one. Wow. So short after Colombia. I was just talking about that. Is there a ping pong effect? Are these earthquakes bouncing off each other? I just released a video about this actually. The reviewed USGSW phase solution, the beach ball, puts this earthquake at magnitude 7.73 with a source depth, the epicenter depth of 13.5 kilometers. That is a little over 8 miles. That is shallow, and we know big and shallow, not good, because the shaking around the epicenter especially is very violent if there's structures in the area, and this is highly densely populated. So very powerful earthquake beneath the Flores Sea, roughly 68 kilometers, 42 miles northwest of Ende in Indonesia. I'm sorry, Indonesia again. And now the BMKG has now raised parts of the tsunami warning to SIAGA. I'm telling you what that means. That means modeled tsunami heights of 0.5 meter to 3 meter. That's roughly 1.6 feet to almost 10 feet. And you only need 3 feet to have a very, very deadly situation with tsunamis. It can wipe you off your feet, take you under, wipe you out, or wash you out to the sea. So this is dangerous. Affected coastlines, of course, right, you see this on the map where the epicenter is, with instructions for people in those areas to evacuate immediately, search higher ground. Right now, I do not have any models for tsunamis above 10 feet. Hopefully, this remains that way. And right now, there's still no reliable, confirmed, like how many people are lost, casualties or anything. No comprehensive damage account right now, because this just has happened. But USGS puts the shaking alert at orange, so we will have damages. But there is already a casualty model. USGS thinks between 10 and 100 people lost so far. But guys, this is not confirmed. This is a computer-generated probability based on the strength of the shaking, how many people were exposed, and the vulnerability of buildings. That is always important in the affected area. Model shaking close to the earthquake reaches a severe number, severe. So this is not just a huge earthquake somewhere far out of sea. This is near densely populated area. Potential for serious impact is already in the modeling. And now let's have a look at what kind of earthquake this actually was, because this explains why a tsunami warning was issued so quickly. The moment tensor is very clear here, guys. The beach ball, that blue beach ball, this was dominated by reverse or thrust faulting. Very simple terms, the crust was being squeezed together and one block of crust moved upwards relative to the other. And whenever we have any vertical movements, when a fault ruptures, that is the tsunami factor. Like a fault, San Andreas, strike slip, sideways, usually you don't need to worry about tsunamis that much. But if anything goes up vertical, bathtub effect, that displaces water. That matters enormously, right? Especially when the rupture is underneath the ocean, like it is here. So thrust earthquake can physically lift or lower the seafloor. Move enough ocean floor vertically fast enough, and the water above it has to move as well, physical law. So that is the basic mechanism that is generating a tsunami, and the moment tensor is overwhelmingly tectonic. USGS solution shows 95% double couple motion. So that's classic fault rupture. This is not some volcanic explosion, not a collapse event, not some mysterious pressure blast beneath Flores. Major tectonic rupture. Both pointers of the beach ball strongly towards compressional reverse type movement. Right now, we cannot simply look at the beach ball and declare what actually was the real fault plane. Aftershock distribution and eventually a finite fault solution should help us tell us which fault actually ruptured. And that takes us to the fault itself, because this earthquake did not occur on the main Java Sunda Trench that is south of Flores, that you would normally think is the culprit for something like that. It actually occurred north of Flores in a very different but in an extremely important compressional system. The leading candidate right now is it's called like the Flores back arc thrust system, or a closely related thrust structure in that back arc deformation zone. So south of Flores, and I mean, you already see Australia on that map here. The Australian plate is being driven beneath the Indonesian island arc. So, but that enormous convergence is not accommodated, unfortunately, only by or only at the trench. The crust behind that volcanic arc is also being compressed. So north of Flores and the neighboring islands that are there, that compression has actually created the Florence back arc thrust. That's the name. This is a major zone, really big, where crust is being pushed over crust. So we have a documented major shallow thrust earthquake on this system that had happened before. And the location plus this earthquake's reverse mechanism make that system extremely important tonight. But until the actual rupture plane is mapped, I would prefer not to tell you that we know exactly, that we can really name the exact fault segment with absolute certainty, but we definitely know what we're dealing with there. There's a historical fact about this location, and we cannot ignore that. That's very important. In December 1992, Flores was hit by another enormous earthquake, 7.8. That earthquake has generated a devastating tsunami and has ended almost more than 2,500 people. Look at the coordinates. The 1992 earthquake was around 8.48 degrees south, 121.84 east. Today's earthquake is around 8.31 south, 121.35 east. So those epicenters are roughly 57 kilometers. That's 36 miles apart. So I'm not saying today's earthquake is a repeat of 1992, but similar. That tells you how devastating this earthquake could become or could be. Does not mean that tsunami will behave in the same way, hopefully not. And it does not prove that the exactly same patch of fault has ruptured, but that closeness tells you what we're dealing with here. Tectonically, this is extremely relevant history, I would say. This part of Flores, because that's the history, has already shown us, demonstrated that a shallow earthquake in the upper 7 magnitude range can produce a destructive tsunami. That's why everyone's so worried about that. And there's another reason why the tsunami situation needs to be watched carefully. 3 meters, 10 feet is a warning, does not mean a uniform 3 meter, 10 feet wave everywhere is moving towards every spot of the coastline. You have to look how the coastline is is situated geologically. Do we have flat coastline? Do we have cliff coastline, right? But this is still a modeled threat category. Evacuations taking place right now, searching higher grounds. Actual heights can vary dramatically from place to place along that coastline. Shape of the coastline, the water depth that is in front of the coastline. If we have bays, harbors, and the direction of the rupture can concentrate energy in some locations, while other locations might see considerably less. And a tsunami height at the coast is not necessarily the same thing as the maximum run-up farther inland. Sometimes the second, third, fourth wave are the ones that are really, really damaging. And that's why the number I'm waiting for now is not another model. It's an actual observation from the real tide gogs that are there along the coast. I want to see what's happening at the coast. Still, right now, no authoritative tsunami height in the information. Let's move back underneath the ground because the earthquake sequence became energetic, absolutely, almost immediately, right? Magnitude 7.7 struck first. Only 15 minutes later, another earthquake appears at approximately magnitude 5.9, now 6.1, northeast of Labuan, Baguio, and only several minutes after that, another magnitude 5.6 appears northwest of Ende. That is a powerful early aftershock sequence, right? And now you see this is the updated map. I mean, after a magnitude 7.7, don't get me wrong, a strong aftershock sequence is expected, right? It's not that we're like, ooh, what a surprise. And in fact, an aftershock well into the magnitude 6 range would not be extraordinary after a main shock this large. Important question is going to be, where are those earthquakes lining up? Because they can answer a lot of questions that we have. And after the first magnitude 6 earthquake, we have another magnitude 6, 6.1. So they keep coming. Aftershocks can begin to draw the rupture beneath the sea, like almost like dots on the page, right? If you look at the epicenters, where are they? This tells you where the fault is rupturing, actually. This is highly, highly interesting. So they organize along that shallower dipping nodal plane. If they do that, that's an interpretation where we know the fault is. If they organize along the steeper plane, that would tell us something different. And if seismicity starts extending beyond the original rupture zone, then we have to shift our attention to neighboring fault systems. But there was also an earthquake before that, magnitude 7.7, August 2nd, just 12 days earlier. Magnitude 4.6 earthquake occurred about 65 kilometers, 50 miles northwest of Ende. So if we look at that geographically, that's remarkably close to today's epicentral area. But the magnitude 4.6 was much deeper, roughly 32 miles, 51 kilometers. So I would be careful about like calling this earthquake a foreshock. Foreshock is defined retrospectively because a larger earthquake eventually occurs nearby, right? But only the geographical proximity alone does not prove that the two earthquakes basically ruptured the same fault surface. The depth difference here is what's significant, right? And it's worth investigating. But right now, this 4.6 is not evidence that someone could have predicted this 7.7 12 days ago. Now the human side of this becomes extremely important. Earthquake happened roughly at 6 o'clock in the morning local time, means seismic instruments can tell us almost immediately how big the earthquake was. They can estimate shaking within minutes, they can model a tsunami potential, but they cannot instantly tell us what happened inside every coastal village, every house, every road, every isolated community around Flores. This information is going to come in slowly. Be careful with what you see on social media. There's too many bot and fake channels. There's bot farms where they have 500 people posting bullshit immediately, fake videos, old videos saying this is what just happened there. So information takes time. Communications can be disrupted. People have to reach the damaged areas. Hospitals have to report. Local officials have to verify reports before numbers become really reliable. So the absence of any confirmed people that are lost right now should not be interpreted as proof that there were no casualties. I will keep you updated about this for sure. So if you're new here, subscribe to the channel, click the notification bell so that you get the next update immediately, guys. And if you want to know, can this be a ping pong effect? What is going on? Or what is right now going on in California? Watch one of these two videos because it's highly, highly interesting. If you're interested in earthquakes, you should really watch this. I see you very, very soon. I'm very sure with another update about this one. Stay safe, guys. Bye-bye.